Hello students, welcome to your classical mechanics class. In this lecture, we will discuss about the conservation of linear momentum. We will start from the homogeneity of space. What is homogeneity of space and how these things leads to conservation of linear momentum? We will discuss in this chapter. And property of space, homogeneity of space, isotropy of space, these are discussed in another lecture. You can go through that lecture in another video on your YouTube channel. So let us start for the homogeneity of space and how it leads to conservation of linear momentum. Suppose we have a frame of reference whose this is x-axis, y-axis, z-axis, g-axis, and this is origin O, and let it be S frame of reference. Suppose another frame of reference S prime whose x-axis, y-axis and z-axis are parallel to the axis of this S frame of reference, and their origin O prime is apart from the origin O of S prime by a distance, let it be A. Now suppose we have 2 points in S prime frame of reference. Point 1 and 2 have their position vector x1 prime and x2 prime, and at these points 1 and 2, let m1 and m2 be the two masses located at these points. In S frame of reference, the position coordinate of this point point 1 is x1 and point 2 is x2. Now from the diagram we have x1 prime is equal to x1 minus a and x2 prime is equal to x2 minus a. You can see this x1 is equal to x1 prime plus a. So I write it as x1 prime equal to x1 minus a, and this x2 prime is equal to this a plus x2 prime. So I write it as x2 prime equal to x2 minus a. Now the homogeneity of space leads to the potential energy U x1 x2 is equal to U prime x1 prime x2 prime. Now with the help of this equation number 1, we can rewrite it as U x1 x2 is equal to U prime x1 minus a x2 minus a. I have used the value of x1 prime and x2 prime from equation 1 here, so it reduced to this form. So let it be question number 2. Now this U prime is function of x1 a x2 a, that is this is the function of coordinates in S frame of reference. So it is better if we write it as U x1 minus a x2 minus a. By I removed primed quantity because now it is a function of unprimed quantity, so I reduce U prime to U. Now with the help of Taylor series we can write it as U x1 x2 minus a curl U upon curl x1 minus a curl U upon curl x2. So let it be equation number 3. Now here I have reduced this form. What was this? This was U prime x1 minus a x2 minus a. Now from the homogeneity of space we know U x1 x2 is equal to U prime x1 prime x2 prime. Now this U x1 x2 is equal to, from the homogeneity of space is U x1 x2, so this term is cancelled. So I can write it as minus a curl U upon curl x1 minus a curl U upon curl x2 is equal to 0. So I can write it as minus a is common, curl U upon curl x1 plus curl U upon curl x2 is equal to 0. So this can be written as curl U upon curl x1 plus curl U upon curl x2 is equal to 0. Now this is curl U upon curl x1 is the gradient of some scalar function. So this scalar function is potential. So it is equal to some quantity force. This is gradient with respect to x. So this is the x component of force. So curl u upon curl x1. Now this x1 and x2, so this will represent the force on particle 2 or on particle 1 due to particle 1 or particle 2 respectively. So we will write it as force is the negative gradient of some scalar function if forces are conservative in nature. You can go through the previous lecture on conservative forces for this. So I will substitute this value, this fx equal to minus curl u upon curl x. Now it is in this equation it is x1. So I will write it as fx 2 1. What is this 2 1? 2 1 represents the component of force on particle 1 due to 2, and I will write this term curl u upon curl x2 with negative sign as fx1 2. This represents the x component of force on particle 2 due to 1. So I will substitute these values here. So it will be fx 2 1 plus fx 1 2 is equal to 0. From here we can write it as fx 2 1 is equal to negative fx 1 2. What is the meaning of this equation? Force on particle 1 due to 2 is equal to negative of force on particle 2 due to 1. That means force are equal and opposite. What is this? This is nothing, just Newton's third law. So that means homogeneity of space leads to Newton's law of motion. So we can say that Newton's law of motion is a consequence of homogeneity of space. Now according to Newton's second law, force is equal to F is equal to m p. What is p? Momentum d v upon dt. So this is, I am rewriting it again, dv upon dt. So this is the definition of force according to Newton's second law. So I will use this definition in this equation. It will be fx21, we will write it as m1 dv1 upon dt plus m2 dv2 upon dt is equal to 0. So I can write it as d by dt m1 v1 plus m2 v2 is equal to 0. So what is this m1 v1 is linear momentum p1 plus p2. Rate of change of this linear momentum is 0. So this is 0 only if p1 plus p2 is equal to constant. So what was the title of this article? Homogeneity of space and conservation of linear momentum. So this means p1 plus p2 is equal to 0. That means the linear momentum of the system is constant. In this case we have started from the homogeneity of space. So this is the law of conservation of linear momentum. Hence law of conservation of linear momentum follows from the linear uniformity or the homogeneity of space. So in the next lecture we will go through the isotropy of space and conservation of angular momentum. Thank you for watching.